So can you find the length of that whole red tangent segment? Okay, are there any ideas on where to start with this? Okay. Okay. So good. So if we describe that, you make triangles out of each of these radii, so we can label the length, 8 and 3. Right? And also we create these two triangles, right? And because the tangent and radius intersect at right angles, we have these two right triangles. Right? And so the additional property of this is we have this pair of vertical angles that are equal. So what do we know about these two triangles? They share a pair of angles that are equal, so by AA similarity, we know these are similar triangles. So that means that these triangles have pieces that are proportional, right? The corresponding parts of these similar triangles are going to be proportional. So what that means is if this whole length is 22, can we identify what part of that belongs here in this larger triangle? What is the ratio of their parts? So their parts have a ratio of 8 to 3 or 3 to 8. You can think of it either way. So what fraction of the whole thing is this part? It's 8 parts out of 11, and the whole thing was 22. So what is that length? 16. Okay, which means what's left for this portion over here? The whole thing was 22. That is 6. Okay. Now, what do you notice about these triangles? Again, you can maybe do Pythagorean theorem, right? And that's fine, but you might be able to see something else. Amita. For mhm. Okay, so careful on that because a chord is going to have endpoints on, or you mean right across here? Just be careful on that because the chord is going to have to go all the way through the circle. But just look at the measures of the triangle. What do you notice about that triangle? A leg of 8, a hypotenuse of 16. Is that something that might be familiar? And what is the relationship? The hypotenuse is double the length of the leg, so what kind of a triangle are we dealing with here? It's a 30, 60, 90, right? Okay, this fits the pattern of a 30, 60, 90. So this is the one other place where you might see this. If you can recognize if one leg is half the hypotenuse, then it has to be a 30, 60, 90 triangle. So what is this portion of this left triangle going to be? It's opposite 60 degrees, so we take the shorter leg and do what with it? Multiply by root 3. So 8 root 3, and then what's this leg going to be? 3 root 3. So what's the total length of our common internal tangent? 11 root 3. Perfect. Okay, so do you see how like a lot of the different pieces can fit together in one type of problem? All right. Now, if it didn't fit this pattern, and they're not always going to fit one of the common patterns that you have, but if it didn't fit the pattern, then what you would have to do is use Pythagorean theorem. And so some of you may have done that if you kind of worked ahead or if that's what you saw. If you can see the pattern, usually that makes it simpler because I didn't have to use a calculator to do any of this work. All right, questions on this problem about the steps that I took? Susie. The ratio was what was, I look at the radius for each of these, the corresponding radii are 3 to 8, so I set up my ratio that way. Any other questions on that type of problem?